Hi everyone and welcome to our Forum 6 wrap-up. This week we took a look at t-testing, what it is, how it's used, and the information it can provide us. In his video, Dr. Capper breaks down the basics involved with the t-testing process. To summarize, all three types of t-testing are designed to compare two measures to each other. These two measures may compare the differences between two independent groups composed of different individuals, or the same group measured two times, such as a pre- and post-test design. We have three types of t-testing: the one-sample test, the independent t-test, and the dependent pairs t-test. The one-sample t-test is used to compare a sample to its population. For example, we may want to compare a group of basketball athletes at a particular school to all basketball athletes across the U.S. of the same population. We use the independent samples t-test to compare two different samples from the same or different populations. Perhaps we want to compare the recovery time for ACL patients living in Milwaukee to the recovery time of ACL patients living in San Francisco. Lastly, the dependent sample t-test is used to compare a sample to itself. Let's say we've designed a new training regimen to improve VO2 max. We could use a dependent t-test to measure VO2 max in a group of recreational athletes, then administer our new training regimen, and follow up with a remeasure of VO2 max to observe for significant treatment effects. We had a few questions regarding when to use the t statistic versus the z statistic. In order to compute the z statistic, remember, we're required to know the standard deviation of the scores in the population. Whereas, with the t statistic, the variance is estimated for the population by using the variance in the samples to calculate the standard error. Basically, if the population standard deviation is unknown, we're going to use a t-test. Since we use the standard error in our t-test formula, this introduces the probability of additional error to take place. Therefore, to adjust for this error, the t-distribution chart was constructed to determine the critical values associated with rejecting our null hypothesis. Notice the shape of our t-distribution will differ from the traditional z-distribution depending on how many subjects we have in our sample. In the picture to the right, we can see these curves overlap. The t-distribution curves represented by the df of 9 and df of 1 visually have a lower mean peak and wider tails, creating an altered curve when overlapped with its z-distribution. So what does this all mean? Several of you stated in this week's forum that things are murky because you're lacking in practice. So let's take a moment and walk through an example from start to finish using SPSS. We'll use an actual published study for this example. Additionally, we'll assume that we have met all the proper assumption criteria associated with performing t-testing calculations, and we will be testing our data at the 0.05 alpha level. In 2004, Brody et al. Wanted to conduct a study to determine the differences between smokers and non-smokers in regional gray matter volumes and densities. Our identified study variables are smoking status, which is our independent variable, and frontal lobe volume, which is our dependent variable. In order to determine which t-test to use, let's examine the following. Question 1. Ask yourself, how many groups do we have? In this example, we have two groups, a smokers group and a non-smokers group. Question 2. Based on the information above, are these groups dependent, meaning that the same individual is receiving a pre-test, followed by an intervention, followed by a post-test? Are the groups independent, meaning we have two groups composed of different individuals? Or do we have a single group being compared to the greater population? So what do you think? You probably guessed it. In this example, we have two groups of different individuals. So we have one group of smokers and one group of non-smokers. Two distinct different groups composed of different individuals. Our last question here, question 3. Based off all the above information, what type of t-test will we select to analyze our data? So if we put all this together, we know we have 3 t-tests to choose from. Which one will you choose? And hopefully this was your answer. We're looking at using an independent t-test. So as you can see, the research question you ask determines which statistical test you will use to analyze your data. Now that we have decided on the type of test we'll use, let's formulate our null and alternative hypotheses. We'll begin with the null. Take a second, pause this video, and write down your null hypothesis. Does it look something like this? Remember, the null indicates that the intervention does not produce a significant difference between the group means. Now let's take a second and create an alternative hypothesis. Again, pause the video to construct your hypothesis. Does it resemble this? Hopefully you came to these conclusions. Remember, in a research design, you're attempting to disprove the null hypothesis in order to show a causal effect resulting from your intervention. Now that we have identified our variables, created our research question, and constructed our hypotheses, let's examine how we will input our collected data into SPSS. I have 2 pictures on this slide. Please note that these are 2 separate screenshots of the same screen. The screenshot on the right is what we would see if we scrolled down from the screenshot on the left. Once collected, we'll place the dependent variable data into one column and the grouping variable in another column. As you can see here, column 1 contains all of our measured outcome data represented by the label frontal brain volume. And column 2 displays our group designations represented by the label group. In this column, a 0 represents a non-smoker and a 1 represents a smoker. Once all the data has been collected and entered into SPSS, we can run the independent samples t-test. Let's examine the independent sample t-test data from the previous slide. So we ran the test, and here's the first box of output data provided to us. It contains our 2 groups, the number in each group, the mean measures, the standard deviation, and the standard error of the mean for each group. When we examine the group means, we notice the non-smoker group has a higher mean frontal lobe brain volume as compared to the smoker group, roughly 5.33 and 4.29 respectively. We've observed a difference here, but we need to ask ourselves, is this difference significant? Okay, so we have a partial table here. This is the second table for the output that SPSS is going to give us. We need to keep in mind that one of the assumptions for using an independent samples t-test is that we have homogeneity between our sample groups. SPSS is going to use Levene's test to determine this. If our Levene statistic is greater than 0.05, we can assume the 2 groups are close to equal in variance. In this situation, we can see that our Levene's value is 0.679, so we're looking at the top horizontal row here. So we've satisfied the condition of this assumption. As we continue to move from left to right on this table, you'll notice that the calculated t-value that is provided to us, along with the degrees of freedom and significance value for our 2-tailed test, are all there. Since this significance value is less than our pre-established value of 0.05, we can reject the null hypothesis and accept the alternative hypothesis and state the difference between the frontal brain volumes between smokers and non-smokers is statistically significant. We see that our p-value here is 0.004, so this means that the probability that our results are incorrect or took place by chance would only be in 4 out of every 1,000 smokers. I hope this brief PowerPoint has started to put some of the puzzle pieces together for you. While on site, Dr. Capper will walk you through this process step by step in more detail. Great discussion this past week, and keep up the good work.